So now we're going to venture into chapter 2, and we're going to look at linear equations in two variables. So today we've only seen linear equations with an x. Now we're going to look at ones with an x and a y. So the first one, let's interpret a line graph. So here I have a line graph with the personal spending on Medicare, and I also have the spending in billions of dollars compared to the year on the horizontal axis. So this is presenting information based on what we've been given in the coordinate plane that Rene Descartes came up with. He's a French mathematician. So what we did was we actually plotted at 2005, there were $1,700 billion spent. In 2006, it looks like there was $1,800 billion spent. So we're plotting this, and we can interpret a line graph by relating one thing to the other. So we can plot ordered pairs. When we're looking to plot ordered pairs, we have a special point called the origin. The horizontal line is the x-axis, and the vertical line is the y-axis. In the ordered pair, the first number tells you how far to move left or right. In this ordered pair, the second number tells you how far to go up or down. Positive numbers go up in the second, negative numbers go down. In the first, positive numbers go right, negative numbers go left. So the position of any point in the plane is determined by two things: the location on the x-axis and the location on the y-axis. So this makes up what we call the rectangular, the Cartesian, or the coordinate system. You can see any of those words in the definitions in the chapter. The numbers, when we look at the x comma y, those are components. So I have an x component and a y component, and I use those components to plot the points that correspond to the numbers given. So looking here, I can also divide the graph into four, like Foursquare. It moves quadrant 1, 2, 3, and 4, and it doesn't move counterclockwise, which sometimes can be hard to remember. The point 3, 2 means I go 3 to the right, 2 up, and then I draw my points. The point negative 5, 6 means I start back at the origin. I go left 5 because it's negative, up 6, and there's that point. Back to the origin, I go negative 4 would be left 4, negative 5, down 5. So that's how we're plotting these actual points and then telling them what quadrant those points are in. If we want to find a coordinate pair that satisfies an equation, this is an input-output. The first number is the value for x, which is your input. The second number is what we call the output. So if I replace x with 0 here, and then I solve it for y, that gives me negative 3. So the solution is 0, negative 3. And I fill in my table. Now, it's still input output, but I have y over here, so I'm going to input 0 for y. So we'll see it's a little bit different when the equation is solved a little differently. Then I'm going to solve for x, and I have the solution 4, 0. So notice this isn't anything that you're getting from a graphing calculator right now. You have to do the number crunch. I'm going to replace it with negative 2, solve for x, I get 4/3. Replace x with negative 6. So when we get to the input output, that's going to be when we have it solved for y. So we're going to get there. The graph of an equation is the set of points that corresponds to the ordered pairs. So every equation, like y equals 2x plus 2, it's a set of ordered pairs. Yes, it looks like a line in the graph, but we're describing every ordered pair that when I input the x value, I output the y value. That's the significance of what a graph is representing to us. A linear equation in two variables, which is when we have x and y, can be written in the form, we call this the general or the standard form. A number times x plus a number times y equals a number. So what can I do with that? How can I begin the process of graphing? The best way to graph, especially in the lab, is to find the x and the y intercepts. It's the easiest way to do this. It doesn't matter how the equation is solved. It doesn't matter what it looks like if it has negative numbers. This is always the easiest one. To solve this and to graph the equation, we're going to let y equals 0, and that finds the x-intercept. So I know sometimes that can be confusing. When I'm plugging in 0 for y, it gives me the number on the x-axis. When I plug in 0 for x, it gives me the number on the y-axis, so it's going in opposites, right? So let's look at 2x minus y equals 4. If I want to find the intercepts, I'm going to let y be 0 first, and that's going to find my x-intercept. So I'm going to divide both sides by 2, and I got x equals 2. Then I'm going to find my y-intercept. I'm going to let x equals 0. I'm going to solve for y, and I get y equals -4. I have these 2 points. In the lab, you're going to click on the line that has the 2 points on it. You're going to plot 2, 0, 0, -4, and it's going to connect them automatically. So this checking isn't really necessary in the lab. You're going to plot your 2 intercepts. It's going to do that, and then it should automatically draw the line through them. The third point is not needed in the lab. You only use 2 points. So again, if I want to graph this, I'm going to find the x-intercept by plugging in 0 for y. This one's a little bit nicer. And I get the origin. That's okay. I'm going to plug in for the y-intercept, and I get the origin again. Now I have a problem. The lab will not graph with 1 point. So you're going to have to find a third point on the graph if you want to graph that in the lab. So just plug in 1 so that you have 2 distinct points to graph. So I'm going to go to 0, 0, which is my intercept. I'm going to go to 1, 3, and it's going to automatically draw the line through. So the only time you would pick any other number to plug in for x would be if your x-intercept and your y-intercept happens at the origin. Now I want to recognize equations that are special. If I have y equals 3, that's going to be something in the lab where you're going to select a specific line. You're going to select the horizontal line, or you could select any line and put 2 dots on this horizontal. If you get the equation y equals a number, it will always be the horizontal line at that y value. If you get something with x equals a number, like here, x equals -2, that's going to be a vertical line, and you can choose the line tool and put 2 dots as long as they're vertical on that x coordinate, and it will connect them for you. So horizontal line is y equals a number, which I know is confusing because the y-axis is vertical. A vertical line is x equals a number, and again, it's the opposite because the x-axis is horizontal, but x equals a number will graph it. Now let's look at the midpoint formula. When I'm using the midpoint formula, I'm adding the x-coordinates, dividing by 2. I'm adding the y-coordinates, dividing by 2. It will always give you a point for your answer. Not a number, a point. So I'm going to take the x-coordinates, I'm going to add them and divide by 2. Take the y-coordinates, add them and divide by 2, and there's my answer. I can simplify 12 over 2, and I could do -1.5. In the lab, in general, we're going to want to leave these in fractional form. We're not actually going to want to do the decimal division there.